This video will explain the notes on probability. So probability, by definition, is the chance of an event occurring. And then probability is always expressed as a percentage or a decimal. So as a percent, it winds up being between 0% and 100%. As a fraction or as a decimal, it becomes 0.0 all the way to 1.0. Okay, so all events have a probability between kind of 0 and 100%. And kind of in those bullet points there, obviously if something has a 0% chance of happening, that means that it is impossible. It will not happen. And if it is 100% probability, then that means that event is going to happen. If it's somewhere in the middle, the closer that it is to 100, the closer that event is going to happen. The closer it is to 0, the less likely that event is going to happen. Okay, so examples of probability. If you go on a weather app and you have a precipitation, what is the chance? They say that there is going to be a 30% chance of rain showers. Then that means that it could happen, but it's more likely it is not going to happen than it is. Okay, now it's not an exact science, but that is just an example of probability. So some other definitions in there. An event is just what you're looking at. All right? So the weather as the example, that's the event. Flipping a coin, right? That is an event. Rolling a die when you're playing a board game, that is an event. All right? A spinner, that is an event. Okay. If you're doing some observations and you're observing, how many times a car of a certain color goes down the road. The event there is each time that you see a car going down. That is the event. Okay, it's the collection of all of what you're looking at. Okay, all of your coin flips, all of your rolling of your die. Okay, all of the instrument models that go into that weather probability. Okay. Probability theory or theoretical probability, that's just the chance that things happen, okay, in theory. Okay. So in theory, when you roll a die that has 6 sides, because it's a cube, when you roll a die, you have equal chance at getting each number. When you flip a coin, there's 2 sides to the coin, heads and tails. You have a 50-50 or a 50% chance at heads and a 50% chance at tails. If in theory, every 100 times that you flip a coin, you should get 50 and 50. That's in theory. That may not be what happens. Okay? So theoretical probability is not a definitive result. It's just, in theory, what should happen. The trials, that would be just how many times that you are performing that experiment. Outcomes, obviously, that's pretty self-explanatory. Frequency, how many times did that happen? So if you're doing experimental probability with flipping a coin, how many times did you get heads? How many times did you get tails? That is the frequency. The experimental probability that has relative frequency, that's just kind of where you take that in saying, we got 20 heads out of 50 coin flips. Well, the relative frequency then would be 40%, okay, because we kind of converted it into a percentage. Okay. Sample space would just be all of your possible outcomes. So if we flip the coin 50 times, you would have 50 kind of 50 results. Each result becomes a part of your sample space. And then the law of large numbers and experimental probability is kind of the more times that you perform that experiment, the more it is going to get closer and closer to what your theoretical probability is. So if we only flip the coin 50 times, maybe it was 40% heads and 60% tails. But if we flip that coin 500 times, maybe we get closer and closer to 50-50. Okay? So that's just what the law of large numbers means. It just kind of means the more times that you're performing that experiment, then obviously it should work itself out to be the theoretical probability. Okay. May not happen, but you have a better chance of that occurring, right, because of the larger scale. The notation of looking at probability, the P stands for probability, so probability of heads, 0.5, or you could write 50%, okay, or you could write 1 out of 2. All of them are fine. You can write probabilities as percentages, fractions, or decimals. All right? I have no issue one way or the other as a preference. So the way you read that, the P and then the parenthesis, you kind of read it, probability of heads, all right, probability of A. And then again, if the probability is equal to 1, it's going to happen. If it's 0, it's not going to happen. Probability should never be a negative number. If you somehow work it out where you have a negative probability, you did something incorrect in your fraction or your division. And likewise, if you get a number that's greater than 1, let's say we're looking at probability of heads, and it's really 1 out of 2, but let's say you did 2 out of 1. Well, that equals 2. That can't happen, right? That means that it's a 200% chance that probability is going to happen. That kind of defeats the purpose of percent. Percent means per 100. You can't have something 200 times out of 100. That doesn't make sense. Okay, so if you ever get a number greater than 1, also, there's some error in your calculation. Oops. All right, so as you kind of look into relative frequency, that's just creating as a fraction. How many times did your event happen out of the total possible outcomes? And the theoretical probability is essentially the same thing. So all of those things are the same formula. It's how many times does something happen, how many total outcomes are there. When we went through counting and permutations, sometimes this is where you need to figure out the total possible outcomes. So what are the total ways that we can choose this group? And then how many groups would you be a part of out of that class? All right, so if there's 20 students in a class, well, if we're picking 3 people to go to the gym, that's a combination question of 20 combination of 3. So we would figure that out. That's the total number of 3-person groups. But then you'd have to figure out how many would you be a part of. All right? So again, that becomes another combination question. Okay, so in that case, we're kind of looking at 20 and the combination this time just with 1. All right. Well, then that would be the number of times that you are in a group. Or you could even do it the other way. How many times would you not be in the group? Okay, you can kind of do the same thing, figure out that probability, and then subtract it from 100 because you want to take the opposite of that. Okay? So again, there's many ways to kind of go about it. That's kind of getting into more of a statistics class, looking at probabilities with the permutations and the combinations. But again, they are all tied together. That's why that introduction happens prior to probability. Right? So you have a background of how do you figure out the number of possible outcomes. Okay? We may not get into the ones that deal with permutation and combination, but definitely the ones with counting. How many phone numbers? Okay, so now we could figure out what is the probability that Verizon Wireless assigns you a phone number that ends in a 7. All right, well, we could figure out how many phone numbers are possible. Then we could figure out how many phone numbers are going to end in a 7, and then we create that probability. Okay, so again, so here's a couple examples. The first one, assign a probability indicated event based on the information provided. A random sample of 500 students at Arizona State University were surveyed. It was determined 375 wore glasses. Estimate the probability that a random student that was selected wore glasses. So you're going to have how many people wear glasses out of how many people were surveyed. We would simplify that down by dividing it 375 divided by 500, and we have a 0.75. So 75% chance that you randomly select somebody that they're going to wear glasses. Okay. Now, if the question was how many people did not wear glasses, you could do 500 minus 375, and you have 125 students that did not wear glasses in this situation, and then you could do 125 over 500, or we could say, well, if it's a 75% chance that somebody would wear glasses, then there's a 25% chance that they don't, because 100% minus 75% is equal to 25. Okay, so there's two different ways you could go about it if that question was changed slightly. Part B, friends of the library host a fundraising lunch. You are on the cleanup committee. There are 4 members on the committee. There's a drawing to determine who will clean the bathrooms. Assume each member has an equal chance of being drawn. What is the probability that you have to clean the bathrooms? Okay. So again, we're looking at the total possible outcomes, which in this case there are 4 people on this committee. Everybody has an equal chance, so that you have a 1 out of 4 chance at being selected. Okay, or 0.25, or you can make it 25% chance. All right, so again, total ways that you would be a part of it, you are 1 person out of the 4 people. So, it's kind of names are in a basket, and you randomly pull a name, you have a 1 out of 4 chance at being selected. Sally photographs sea lions for SeaWorld. During her next session, she's to photograph sea lions eating fish. Based on the knowledge of sea lions, she believes that she'll be successful. What specific number do you suppose she would estimate for the probability of success? All right, so if this is not really a right and wrong question, but what we're looking at here is, as a probability, if she knows it's going to happen, it would be 100%. If she's fairly confident, then she's going to say a number that's greater than 50%. If she thinks she's got probably a hit or miss equal opportunity time, then she'd say 50%. If it's not likely to happen, maybe a 20%. If she knows it's never going to happen, then that would be a 0%. Okay, so based on knowledge of sea lions, she believes she'll be successful. What specific number do you suppose she would estimate for her probability of success? I don't know, 80, 90% successful. Then that's kind of what we're doing. That's just kind of do you understand the scale of 0% chance, 50%, 100. Down here at example 2, looking at the possible outcomes. Okay. So tossing a coin. How many possible outcomes are there? There are 2 possible outcomes. Woo. So we have 2 possible outcomes. Rolling a die. If it's a standard die, there are 6 sides. Tossing 2 coins. You have 4 outcomes. Okay, so looking at that more specifically, you could get heads and heads. You could get heads and then tails. You could get tails and then heads, and you can get tails and tails. Rolling a die and flipping a coin. Okay. Well, you have 6 possibilities, and then you have 2 possibilities, and when you combine things like this, you multiply, so that's going to be 12. Okay, it's like saying we got a 1 and a head. We have a 1 and a tail. We have a 2 and a head, a 2 and a tail. We have a 3 and a head, a 3 and a tail, 4 and a head, 4 and tail, 5 heads, 5 tails, 6 heads, 6 tails. So there are 12 possibilities there. Okay. If you have 3 true-false questions on a test, okay, so you have 3 possible answers that all have 2. So you have 8 possibility all the way. So if we're listing the sample space, that would be saying you have true, true, true. Or you have true, true, false. You have true, false, false. You could have true, false, true. So that covers all of them with the first question being true, right? And then you're going to kind of go through the other combinations, okay? Because you could have false, false, false. You could have false, true, true. You could have false, true, false, and false, false, true. So there's the 8 possible ways, okay? So if you're listing a sample space, I don't recommend that. But what you're doing is you're trying to figure out how many outcomes are there in the first event, 2. Then the second question, event, 2. And then the third one, 2. Multiply them together, just like the rolling a die and flipping a coin. All right. So what's the probability that all 3 will be false? That's right here. So that's a 1 out of 8. Okay. Or we can make it 0.125 or 12.5%. Okay. What is the probability that exactly 2 questions would be false? So you kind of go through, where is that occurring? Right here's 2 falses, and right here is 2 falses, and right here is 2 falses. Okay. This one here has 3 falses. It says exactly. Okay. So we have 3 out of 8. 3 out of 8 would also be a 0.375 or 37.5%. Okay. Actually, looking back at example 1 up there, it was kind of looking at which technique would you use. Again, relative frequency just means you would write it as a percent. I did it as theoretical probability, over here with these answers. If we said that this is 75%, then that's the relative frequency. Okay. Or if we just left it and said the fraction, right, we didn't convert it into a decimal, that's relative frequency. The intuition, that would be this one. Understanding what your belief is. Okay. But the relative frequency would more than likely be that first one, because you're looking at 500 students and it's a random sample, so it's more relative. All right. So we would say that 75% is relatively based on the students that are there. There's no theory there. All right? That doesn't mean 75% of students on that campus or on every campus wear glasses. It's all based on that specific sample. Okay? And then we're using that to kind of explain the results as that percentage. Part B, it's the theory. There are 4 people and there's only one of them that is you. So in theory, it's a 1 out of 4. Okay, and then the last one, like we kind of said, it's more based on what we know or what she knows in this case about sea lions. Some examples here on theoretical probability, just to kind of go through again, number of times that the event happens out of the total possible outcomes total. So you have a ticket randomly selected from 3 green, 4 yellow, 5 blue. Determine the probability of getting a green ticket. So the probability of getting a green ticket is 3 green out of how many are there total? 3 and 4 is 7, and 5 blue makes 12. So you have a 3 out of 4, or I'm sorry, a 3 out of 12, which is really 1 out of 4. So you have a 0.25 probability, or 25% if you want to make it a percentage. The next one has the word or in it. So or means you need to figure out what is the chance of getting a green and what is the chance of getting a yellow, and you kind of combine those. Okay, so there are 3 green and there are 4 yellow. So we add those together and we divide by the 12. So this is a 7 out of 12 chance. Probability of getting an orange ticket. Well, there are 0 orange tickets out of 12. So we have a 0% chance. And then the next one, a green, a yellow, or a blue ticket. Well, if we have 3 plus 4 plus 5, that equals 12 out of 12. So that would be 100% chance. Okay, so that means that it is going to happen. All right, so probability is always a number, and then you can convert it to a fraction. You can convert it to a percentage. And again, either way, doesn't matter, but it's always going to be between 0 and 1. You're never going to get greater than 1. You're never going to get less than 1. And like I said, with the ones with the or, you add them together to kind of create that complementary events, that bullet point there. That little apostrophe after it means kind of not happening. So we could say, probability of getting a green ticket on part A. We could also say, what's the chance of not getting a green ticket? Well, then that's going to be, the 1 minus the 0.25 to make 0.75, or you could say 100% minus 25%. Right? Because the chance of something happening and the chance of something not happening is always equal to 1. Okay? So example 5, if the probability of A is 0.35, then what's the probability of A not happening? You would do 1 minus the 0.35. I'm not sure what that M means. So we would say that's going to be a 0.65. Okay, so this one would be 0.65 because that's 1 minus 0.35. Okay. Example 6, an ordinary 6-sided die is rolled. Determine the chance of getting a 6. So to get a 6, you got a 1 out of 6 chance. Not getting a 6, you have a 5 out of 6 chance. Okay, because there are 5 numbers that are not a 6. Getting a 1 or a 2. Getting a 1 would be a 1 out of 6, and 2 would be a 1 out of 6, so we would have 2 out of 6. Okay. Not getting a 1 or a 2, so you would try to think, how many numbers are there? You have a 3, a 4, a 5, and a 6. So there are 4 numbers out of 6 that are not a 1 or a 2. Okay. So again, just looking at it from 2 different perspectives. Okay. What is it there, or what is it not? Okay. What is the probability that's given, and what is it that is not given? Okay. Probability related to statistics. We'll get to these eventually. The first stuff that we're going to be looking at is just the theoretical probability. But here's what we're looking at, the sample. So in that Arizona State question, it had to deal with 500 students, and you were randomly selecting. Okay, so a probability application is when we're making statements about what will occur when the samples are drawn from a known population. Statistics is when we're looking at the samples are obtained in different ways, and then the inference is made, or the prediction is made about the population. Okay, so if we randomly select 2 students from a class that has 14 boys and 18 girls, what's the probability that both selected from the students are boys? So what we're going to look at there is kind of the probability of it happening. So we're selecting 2 students, so you need both of them to be boys, so we would say 14 out of the 32 in the class, and then we would also multiply it because we're doing 2 events, so it's kind of like looking at it this way. We have 14 boys out of 32, and then we have 13 boys out of 31 that are left. So you got to kind of do that counting stuff where you're going down. All right, but this is going to be just a probability, because all we're doing is we're just looking at the numbers, and now that's what we have. Okay? We're not saying that there's not more detail into this. If there's more detail, then it becomes a statistic. So like the second example, randomly interview 100 students and ask them how much time they spend on sports each week and find the average. Based on the sample, make a conjecture about the average amount of time a student would spend on sports per week. Right? That's a statistic, because now we're going to take whatever our answers are from those 100 students, but now we're going to then use that to explain all students. All right? We're making that inference, we're making that prediction. Okay, so when you do a survey, when you look at a study, a probability is just the fact. What is there in that study? Okay, right here, the fact. How many ways can we get 2 boys picked out of this class? Okay. The next one is we're going to take 100 people, and now we're going to take what their answers are, and we're going to explain that about all students. Okay, so that's the difference between kind of like the probability and the difference between that and the statistic. Okay, so not something we're going to really dive into a whole lot here. It's just a part of this set of notes, and but right now we're going to focus on the probability, theoretical probability, the selecting the ticket question, the rolling of a die question, a flipping of a coin question. And remember, if you have the word "or" in there as a probability, it's the probability of the first event plus the probability of the second event, and a third, and a fourth, and a fifth, and so on and so forth. If it is looking at the word "and," what is the probability of getting a boy and a boy out of that class? Then you multiply. All right, that's why I did 14 times 32, or 14 out of 32 times 13 out of 31. Okay, because once I selected the first student, we're 1 less students and 1 less boy. Okay, so again, if you're looking at the word "or," you add the results together. If it's "and," you multiply them together. Okay, so that's going to be kind of the first part of what we're looking at, just simple probability, and then getting into the compound event probability. So if it's the word "and," you multiply. Okay, so the probability of heads and tails. You have a 1 out of 2 heads and you have a 1 out of 2 tails, so the chance would be 1 out of 4. Okay, if it's the probability of heads or tails, I don't know why you would do that, because then it would be 1 out of 2 plus 1 out of 2. So that would be a 2 out of 2, or a 100% chance. Okay, so the word "or," you add. So like if we said, what's the probability of getting heads on a coin flip and 6 when you roll? Well, you have a 1 out of 2 chance for heads, and you have a 1 out of 6 chance for a 6 on a die. So that's a 1 out of 12 chance. If we said, what is the probability? You flip the coin. What's the probability you get heads or you get a 6? Well, we would have a 1 out of 2 chance for heads, and we have a 1 out of 6 chance, or I'm sorry, 1 out of 2 chance for heads and a 1 out of 6 chance for a 6. but you're adding them together. So now you'd have to add fractions, so it's really 3 out of 6 plus 1 out of 6. So you have a 4 out of 6 chance, okay, which simplifies to 2/3, right, or 67%. Okay. So again, the word or adds, and the word and multiplies. Okay, so that's getting into the compound probabilities. But other than that, we're just always looking at total ways something can happen out of how many ways are possible.